Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's lesson, we will discuss question 1, 2 and 3 from March 2021, paper 2. Part A is simply asking us to complete table 1.1 by writing vector or scalar in front of these given quantities. Acceleration is a vector quantity because acceleration is equal to rate of change of velocity, and velocity is a vector quantity. Power is a scalar quantity because power is rate of transfer of energy. Any form of energy is a scalar. Power is also scalar. Work is also a scalar quantity because work is a way of transfer energy. Means simply is a way to transfer energy from one object to another object without rise in temperature. So work is also scalar quantity. For part B, we need to determine the acceleration of the object from time t is equal to 0 to time t is equal to 4.0 seconds. And for this question, velocity versus time graph is given. Velocity is on y-axis and time is on x-axis. So acceleration is simply equal to the gradient of vt graph. Simply is equal to gradient of vt graph. As the question is asking us, we need to find acceleration from time t is equal to 0 to time t is equal to 4.0 seconds. So we need to find the gradient of this line. We need to find out. First of all, let's try to write down the coordinates of these 2 points. If you look at this point, coordinates of this point are 0, 0.70. If you look at this point, x coordinate is 4.0 and the y coordinate is 1.40. Now we have coordinates, simply we can find out gradient. Gradient simply y2 minus y1 over x2 minus x1. So y2 in this case is 1.0 and the y1 is 0.70 divided by t2 minus t1, and t2 is 4.0 minus 0.0. If we solve this one, our final answer is 0.18 meters per second per second. This is our final answer. For the second part, we need to determine the distance moved by the object from t is equal to 0 to t is equal to 4 seconds. And velocity versus time graph is given to us. It simply means that we need to find the area under this line. We have already found y coordinate, that was 1.40. Now we need to find the distance. We simply need to find this area, and this is a trapezium. So area of trapezium, simply we can write down this is 1.40 plus 0.70 divided by 2, and we need to multiply with time, 4.0. And if we solve this one, our final answer is 4.2 meters. So we can write down our final answer here. Part C1 is asking us to define force, and force we can simply define as rate of change of momentum. For part C2, it is given to us that the motion represented in figure 1.1 is caused by a resultant force F acting on the object. Question is asking us on figure 1.2, we need to sketch the variation of F with time t from t is equal to 0 to t is equal to 12 seconds, and numerical values of force are not required. If we look at figure 1.2, on y-axis we have force, and this is the resultant force. And if the mass is constant, resultant force simply F is equal to ma. Resultant force and acceleration, they always have same direction. So these are two quantities in physics. They always have same direction. So this is very important. Same direction means that when resultant force, this is positive, means this is acting in positive direction, acceleration will be positive. When direction of resultant force is negative, acceleration also will be negative. This is what we need to understand. Now let's try to find out when acceleration is constant, when acceleration is positive, when acceleration is negative, and when acceleration is zero. If we simply look at this velocity versus time graph, velocity is on y-axis and time is on x-axis. Simply we need to find the gradient. If we look at this gradient, means from this point to this point, this gradient is constant and this gradient is positive. So it simply means that acceleration is constant and acceleration is positive. So we can also say in this case force is positive and force means the resultant force is also constant. If we look at the second part, in this case we can simply find out that acceleration is zero because the gradient of this line is zero. So we can also say that resultant force is zero between time t is equal to 4 seconds and t is equal to 8 seconds. That if we look at t is equal to 8 seconds to t is equal to 12 seconds, we can simply find out that gradient of this line, this is negative, so acceleration is also negative. But the gradient of this line is constant, so acceleration is constant, so force is also negative and force is constant. This is how we can sketch force versus time graph, but one thing we have to be careful is that the value of the force here means the resultant force acting between time t is equal to 0 to t is equal to 4 seconds has to be smaller than the force acting between t is equal to 8 to t is equal to 12 seconds, because the gradient of this line is steeper than the gradient of this line. Let me write down here, let's say this force is F1 and let's say this force is F2. So F2 has to be greater than F1. For the second question, part A is asking us, we need to state what is meant by work done. Work done simply is equal to force time distance moved in direction of force, or simply we can say product of force and distance moved in direction of force. This is how you can write your final answer. For part B, it is given to us that a ball is released from a balcony at the top of a tall building and the ball falls vertically from rest. Means the initial velocity of the ball is equal to 0 and finally ball reaches a terminal velocity. And the change in gravitational potential energy is given. This is equal to 60 joules and the ball hits the ground and kinetic energy of the ball when it hits the ground is 23 joules. First of all, let's sketch this problem so you can see the clear picture what is happening. It is given to us that the initial velocity of the ball is 0, so we can simply write down u is equal to 0. And it is also given to us that the gravitational potential energy of the ball decreases by 60 joules. If we take at this point gravitational potential energy of the ball is equal to 0 joules, then we can say that initial value of gravitational potential energy, this is equal to 60 joules. It is also given to us that the ball reaches a terminal velocity. We can write down Vt, and the value of Vt is given, that is 16 meters per second. And it is also given to us when the ball hits the ground, it hits the ground with velocity that is equal to terminal velocity. Velocity has magnitude 16 meters per second. And kinetic energy at this point is also given, that is equal to 23 joules. Question is asking us, we need to find the mass of the ball, and that mass has to be equal to 0.18 kgs. So this is very straightforward question if you understand this problem. Simply we need to use concept of kinetic energy and we can find the value of mass, because kinetic energy is given and the speed is given. So in this case mass is simply equal to 2 times kinetic energy divided by v square, and we have all these values. We simply need to plug in to find the value of mass. So if we solve this one, our final answer will be 0.18 kg, and this is the mass of the ball. Question was asking us show that, so this is our answer. Second part is asking us to calculate the height of the balcony above the ground, but for this question change in gravitational potential energy is given, that is equal to 60 joules. Simply we need to find the change in height. So the change in height is equal to change in gravitational potential energy divided by force of gravity. In this case, change in gravitational potential energy is 60 and the mass of the ball is 0.18 and value of G is 9.81. If we solve this one, we can find the change in height. In this case, change in height is 33.9 meters, or we can say is equal to 34 meters up to 2 SF. Because the least number of significant figures in raw data we have 2, so our answer has to be up to 2 SF. So the final answer is 34 meters. Let's move on to third part. Third part is asking us to calculate the average resistive force acting on the ball. For this concept, we need to use law of conservation of energy. In this case, the work done by resistive forces is equal to change in mechanical energy, means the change in gravitational potential energy minus the change in kinetic energy. Change in gravitational potential energy is equal to 60 and change in kinetic energy, in this case work done by resistive forces, this is equal to 37 joules. Now we have work done by resistive forces, so we can calculate the average resistive force acting on the ball. And work done by resistive forces is equal to resistive force means the average resistive force times the distance, and this is equal to 37. So we can write down average resistive force is equal to 37 by 34, because this is the distance traveled by ball. So if we solve for this, our final answer will be 1.1 newtons. So this is magnitude of average resistive force. Part C is asking us to state and explain the variation, if any, in the magnitude of the acceleration during the time interval when the ball is moving downwards but before it reaches constant terminal velocity. Let's try to understand this one with the help of this simple sketch. At the beginning, it was given to us that the ball has zero velocity and the force acting on the ball at this point is only force of gravity. Now, as the ball is moving down, the resistive forces will increase. So you can see here, as the ball is moving down and the speed of the ball is increasing, so the resistive forces are also increasing, but the magnitude of force of gravity is not changing. So this we can say is resistive force. If we write down our resultant force at this point, Fnet will be equal to mg. That if we write down net force at this point, net force will be equal to mg minus resistive force. If we go to the final point, when the ball has reached terminal velocity, at that point you will see that the forces are balanced, or we can simply say at this point mg is equal to Fr and the resultant force at this point will be 0. Now if we go from point 1 to second point and then we go to third point, means the third position, if we go to this, you can simply see that resultant force is decreasing. Resultant force is decreasing, it simply means that acceleration is also decreasing because resultant force is decreasing. So the first part question is asking us state, so we can write down magnitude of acceleration decreases. So one point you can write down state magnitude of acceleration decreases. Now the question is also asking us, we need to explain, so we can simply explain that as the ball is falling, weight is constant, weight remains constant. We can simply say weight remains constant. So second point you can write down weight remains constant, and resistive force means Fr is increasing with speed, so this is the second point we can write down. And the third point we can say that Fnet decreases. Fnet decreases because Fr increases with speed. So that's all what you need to write down. If you write down these 3 points, you will get 3 marks. For our third question, it is given to us that a spring is extended by a force and the variation with extension of the force is shown in figure 3.1. It simply means on y-axis we have force, this is the force applied, and on x-axis extension, and extension is given in centimeters. Question is asking us state the name of the law that relates force and extension of the spring. Very simple question. So that law is simply Hooke's law. So this is how you can write your answer for this. For part B1, question is asking us to calculate spring constant and our answer has to be Newtons per meter, and force against extension graph is given to us. It simply means that K in this case is equal to the gradient of Fx graph is equal to gradient of force versus extension graph. Simply we have to find the gradient. In order to find gradient, we can take 2 points on this line. Let's say we take this point and we take another point here. This is our second point. Let's write down the coordinates of this point. So coordinates of this point are 5.0, 7.0. Now we can find the gradient, that is equal to 7.0 minus 0 divided by 5.0 minus 0, but this is in centimeters, so we have to multiply with 10 to negative 2. If we solve this, our final answer will be 140 newtons per meter. So this is our final answer. Let's move on to second part. Second part is asking us to calculate the strain energy in the spring when the extension is 4 centimeters. Means when the extension is 4 centimeters. So for this one, simply we need to find this area, or we can use formula. Let me use the formula. You can also check with area later by yourself. Elastic tension energy in this case is 1/2 kx square. We have the value of k we have just calculated. This is 140 newtons per meter, and extension is given, this is 4 centimeters. So we have to convert into meters. Now if we take the square of that, we can find out value of EPE, means the value of strain energy, and in this case that is equal to 0.11 joules. For part C, it is given to us that now one end of the spring is attached to a fixed point, as you can see here is attached to the fixed point. But one thing you need to be very clear is that this is the same spring, the one we have studied in part A and part B. And the other end of this spring is attached to a cylinder, and the cylinder is submerged in a liquid. So this is the other end of the spring. But it is also given to us that extension in the spring is 4.0 centimeters. As the extension is 4.0 centimeters, so we can find the value of the spring force. So value of spring force we can find from here, and this value is equal to 5.6 Newton. So this is important. So this is value of the force when extension is 4.0 centimeters. Now question is simply asking us, we need to find the upthrust on the cylinder. 0.60 Newton means simply we need to show that. First of all, let's try to understand the forces acting on this cylinder. The one force acting on this cylinder downwards, this force is weight, and there are two forces acting on the cylinder upwards. One force is the spring force, we can say this is Fs, and the other force acting on this cylinder is upthrust, so this is upthrust. So this is free body diagram for the cylinder. Simply we can write down, in this case, as the cylinder is in equilibrium, it means upward forces has to be equal to downward forces. Downward force is weight in this case, and upward force is upthrust and spring force. Upthrust plus spring force. In this case, value of the weight is given, that is 6.2 0.20. Value of upthrust is not given to us, but the spring force we have found, that is 5.6. Now if we solve this one for upthrust, we can find out its magnitude. In this case, the value of upthrust is 0.60 newtons. For second part, we need to calculate the difference in pressure between the bottom face and the top face. Mean between this face and this face, we need to find the value of delta P. For this question, we have already calculated upthrust, and upthrust is simply equal to delta P times cross-sectional area. Means the cross-sectional area of this cylinder. Upthrust we have already calculated, that is 0.60 newtons, and delta P we need to find out. Cross-sectional area is also given, that is 1.2 times 10 to negative 3 meter squared. Now delta P is quite straightforward one. If you simply divide upthrust by cross-sectional area, we can find out value of delta P. In this case, delta P will be equal to 500 Pascal. So this is our answer. For third part, we need to calculate the density of the liquid, but in the second part we have already calculated delta P, so we can write down delta P is equal to rho G delta H. This question is asking us to calculate density. We can write down density will be equal to delta P divided by G times delta H. Delta P we have already calculated, that was equal to 500 Pascal. So value of G we can use is 9.81 and delta H is given here. This is equal to 5.8 centimeters, so we can convert into meters. So we need to multiply by 10 to negative 2. Now we can solve for density of the liquid. If we solve this one, density of the liquid is 879 kgs per cubic meter. So this is our answer for this part. For part B, it is given to us that liquid in part C is replaced by another liquid of greater density. We need to state the effect, if any, of this change on the upthrust acting on the cylinder. First of all, let's try to understand what is upthrust. Upthrust is simply equal to weight of fluid displaced. Weight of fluid displaced. Simply we can write down this is equal to rho G times V. Rho in this case is the density of the fluid and V is the volume of the cylinder. V is volume of the cylinder. So if density of the fluid increase, it simply means that upthrust will increase. So we can simply write down in this case upthrust will increase if density of the fluid increases. And the second one is asking us what is effect of that on extension of the spring. If we look at the forces acting on this cylinder, we have already discussed that point, that forces acting on the cylinder are weight, and weight is acting down, and this cylinder is in equilibrium, means the forces are balanced. Upthrust is the force that is acting upward, and there is spring force that is also acting up. Spring force is also acting up. But in this case, weight of the cylinder, this is not weight of the fluid, this is weight of the cylinder. This is constant, this is not changing. Now if the upthrust increases, so the spring force has to decrease. If the spring force decreases, then it simply means extension in the spring that will also decrease. So simply you can write down extension of the spring decreases in this case. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's class, we will discuss questions on waves and Doppler effect from Cambridge AS Physics Paper 2. And this paper is from March 2021. Part A is simply asking us to state the principle of superposition. Principle of superposition simply tells us when two waves meet at a point, how we can find the resultant displacement of resultant wave. Let's try to understand this one a little bit in detail before we write our final answer for this question. You can see here in this figure, I have already drawn three different waves. Let's say this wave is wave 1 and this is second wave, and the third one is resultant wave of these two wave. If you look at this point, you can see the displacement of black wave. So this is displacement of black wave. But at the same point, second wave, it also have displacement. Blue wave, this has also displacement. And this is the displacement of blue wave. But if we add these two displacements together, we can find the displacement of resultant wave. Simply, you need to add displacement of these two waves. Now, let's look at this point now. At this point, you can see blue wave, it has negative displacement. So this is displacement of blue wave. But the black wave, it has positive displacement. And this is displacement of black wave. But if we add these two together, one is positive, one is negative, we can find the resultant displacement of resultant wave. And this is resultant displacement of resultant wave. Now, if we look at this point, wave 1 and wave 2, they have zero displacement. So the resultant displacement of resultant wave is also zero. This is what you need to understand about principle of superposition. Now let's try to write down our final answer. So this is how you can state principle of superposition. Simply you can say when two waves meet at a point, the resultant displacement is equal to the sum of individual displacement of each wave. For part B, it is given to us that a transmitter produces microwaves and these microwaves are traveling in air. Mean air is the medium, very important. And they're moving towards a metal plate. Experimental setup is shown in figure 4.1. We can see here we have microwave transmitter. We also have microwave detector, or simply we can say microwave receiver. Metal plate is also placed at the end. And it is also given to us that the wavelength of these waves is 0.040 meter and stationary waves is formed between transmitter and the plate. Question is simply asking us explain the function of the metal plate. Why do we need metal plate in this case? First thing we need to understand is that stationary wave is a resultant wave of two waves. If there is only one wave, there will be no stationary wave. So it means we need two waves. It means we need one incident wave and one reflected wave. So when those two waves they will meet, they will form stationary wave. So the purpose of this metal plate is to reflect microwaves. So this is very simple how you can answer. If you look at this one, I have already drawn here. So this picture is very clear to see how stationary waves are formed between metal plate and microwave source, or you can say microwave transmitter. Now the function is simply, the function of this metal plate is to reflect microwaves. So this wave is reflected wave. This is reflected wave and this one is incident wave. This one is incident wave. Here is final answer. So this is how you can write down your final answer for this question. For the second part, we need to calculate the frequency of the microwaves, but our answer has to be in gigahertz. Frequency of wave simply is equal to the speed of the wave in the medium divided by wavelength of the wave. In this case, the wavelength of microwaves in air is given, that is equal to 0.040 meters. This is given to us. Now the question is that what is the speed of microwaves in air? We have discussed that all electromagnetic waves, they travel at speed of light in vacuum. So this is speed of electromagnetic waves in vacuum. But the speed of electromagnetic waves in vacuum is almost equal to speed of electromagnetic waves in air. So the speed of electromagnetic waves in air is also equal to 3 times 10 to 8 meters per second. Microwave is also an electromagnetic wave, so its speed is also equal to 3 times 10 to 8 meters per second in air. So simply we can write down here. So the speed of microwave in air is 3 times 10 to 8 meters per second. If we solve this one, our final answer will be 7.5 times 10 to 9. This is answer. But we need to write down our answer in gigahertz. So this is simply 7.5. So our final answer is 7.5 gigahertz. For third part, it is given to us that a microwave receiver is initially placed at position X where it detects an intensity minimum. The receiver is then slowly moved away from X directly towards the plate. Means first of all, detector is placed at this point and this is position X and it detects intensity minimum, means at this point there is node. And then this detector is moved to the right, detects another intensity minimum, or simply you can say node. Node is detected at this point. And question is asking us to find the shortest distance between these two nodes, and the distance between two nodes, it is equal to lambda by 2. So simply we can say distance is lambda by 2, and the value of lambda, that is equal to 0.040 meters. Simply we need to divide this by 2. So this is our final answer for this part. For the second part, we need to determine the number of intensity maxima. It simply means that we need to determine the number of antinodes when the detector is moved from position X to a new position that is 9.1 centimeter away from X. So it simply means that at this point our detector was placed at this position, means at position X. Then we move our detector to the right and the new position from this one is 9.1 centimeter away. We have already discussed that the distance between two nodes, that distance is equal to 0.020 meters, or simply we can say this distance is equal to 2 centimeters. So if we move detector from here to here, so this distance is 2 centimeters. Then if we move to next node, it will cover extra 2 centimeters. If we place at this point, so the distance from X will be equal to 6 centimeters. If we place here, distance between X and this new position is 8 centimeters. In question, we have to move this one by 9.1 centimeters. So it means we have to move up to this point, up to here. Otherwise, simply you can understand, if we move to this one, distance will be 10 centimeters, but we have to move by 9.1 centimeter. So distance between X and the new position here, distance is 9.1 centimeters. Now question is asking us determine the number of intensity maxima. So this is one intensity maxima, so this is 1. So here we have the second one, here we have third one, so this one will be the fourth one, and this one is fifth one. So the total number of intensity maximum detected by detector when the detector is moved from X to new position, that is 9.1 centimeters away from X, is 5. So total number of maxima is equal to 5. For question 5, it is given to us that a source of sound is moving in a circle and the radius of the circle is 2.4 meters. And source of sound is moving at a constant speed in a horizontal circle and the speed of source is given, that is 12 meters per second. And frequency of source is also given, means the frequency of sound produced by source is given, that is 950 hertz. So we can simply say this is fs. In this case, f is equal to 950 hertz. And speed of sound in air is also given to us, and it is also given that observer is at rest. We need to calculate the minimum frequency, and in our answer we need to use three significant figures. First of all, let's try to understand when the frequency is minimum. Frequency is minimum when the source is directly moving away from listener. So here frequency will be minimum, and frequency heard by listener will be maximum when source is moving towards listener, directly towards listener. Directly is very important. When directly moving away, frequency will be minimum. When directly moving towards listener, frequency heard by listener will be maximum. Question is asking us to find the minimum frequency, so we need to simply use Doppler equation when the source is moving away and listener is at rest. So f minimum in this case will be equal to v over v plus vs times frequency of source. Speed of sound is given to us, and this v is also speed of sound, and vs is speed of source that is given, that is equal to 12 meters per second, and frequency of source is 950 hertz. We simply need to solve this one to find the minimum frequency observed by this listener. In this case, our answer is 917.6 hertz. But the question is asking us, we need to write our answer using three significant figures, means our answer must have three significant figures. So we can write down our answer 918 hertz. So this is our final answer, and it has three significant figures. For part B, question is asking us to calculate the shortest time interval between minimum and maximum frequency observed by listener. For this question, it is given to us that the source is moving in a circle and radius of circle is 2.4 meters, and the speed of source is also given, that was given in part A, and the speed of source is 12 meters per second, and the source is moving at a constant speed. Let's try to understand when the frequency is minimum. Frequency is minimum when the source is directly moving away from listener, so we can say frequency will be minimum at this point, and frequency will be maximum when the source is moving directly towards listener. You can also look at this diagram. When the source is moving away, in this case directly away, frequency will be minimum, and when the source is moving directly towards observer, means towards listener, frequency will be maximum. Now if we can find the shortest distance between these 2 points, then we can simply divide by velocity, mean the speed of source, and we can find the shortest time interval. First of all, let's try to find out shortest distance, mean the shortest distance between 2 points, and the shortest distance is simply equal to 2 pi r divided by 2, or simply we can say this is 3.142 multiplied by the radius. Radius is 2.4. We need to find shortest time, means the minimum time, that will be equal to minimum distance between 2 points, mean between this point and this point. So this is the minimum distance, and we need to divide by the speed of source. So if we solve this one, our final answer is 0.63 second. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's class, we will discuss questions on electricity and radioactivity from Cambridge AS Physics Paper 2, March 2021. Part A is asking us to state Kirchhoff's first law. And this is very common question in past papers. Sometimes in exam they will ask you to state Kirchhoff's first law. Sometimes they will ask you to state Kirchhoff's second law. So you need to be very clear about these two laws. Let's try to understand what exactly Kirchhoff's first law is. We can understand this one simply with one very simple circuit. As you can see here, I have drawn this circuit now. Let's say the EMF of power supply, this is V0, and this resistor is R1 and the second resistor is R2. And also let's assume that current coming from the battery in this circuit is I0, and current passing through resistor 1, this is I1, and current passing through second resistor, this is I2. Now according to Kirchhoff's first law, at any junction, let's say if we study this junction, meaning if we look at this junction, according to Kirchhoff's first law, I entering has to be equal to I leaving. I entering has to be equal to I leaving. Means the total I entering has to be equal to total I leaving. In this case, current entering this junction is I0, and current leaving this junction is I1 and I2. So this is simply Kirchhoff's first law. Let me explain to you how you can write a proper answer. This is how you can write your answer for Kirchhoff's first law. Simply you can say at a junction, the total current entering the junction is equal to total current leaving the junction. For part B, circuit is given to us. As you can see, it is given in figure 6.1. In this circuit, we have a power supply. So this is battery, or simply you can say this is power supply. So this is over battery, and this battery has internal resistance, and EMF of this power supply is 12 volts. Total current coming from the battery, that is also given, that is 3.6. One lamp is connected here. You can see this is lamp, so this is symbol for lamp, and resistor is connected here, and current passing through resistor, this is also given. This is 2.1. But in figure 6.2, you can see the IV characteristics curve for the lamp is given, means we have graph between I and V for the lamp. And part B1 is asking us to calculate the resistance of the lamp in figure 6.1. This is figure 6.1. The resistance of this lamp is not given, and we can find current passing through this resistor. So this is 2.1, so current passing through resistor, this will be 1.5, because the total current means the I total, this is equal to I means current passing through lamp plus this is I passing through resistor. So if we need to find I lamp, so this is simply equal to I total minus IR. In this case, I total is 3.6 minus we have 2.1. So current passing through this lamp, this is equal to 1.5 amps. Now the current is given for this lamp, means the current passing through this lamp is given. So we can find out the voltage across this lamp, and the voltage we need to look at IV characteristics curve. So this is I, and on x-axis we have V. So when current is 1.5, you can look at this point, value of V is 4.4. So this is value of V. Now we have the potential difference across this lamp, and we have current passing through this lamp. So R we can simply calculate by V over I. Means simply we can use Ohm's law. So this is 4.4 divided by I, and I is 1.5. If we solve this one, our final answer will be 2.9 ohm. So this is our final answer. So we can write down here our final answer is 2.9. Second part is asking us to calculate internal resistance R of the battery. Means we need to find the value of this resistance. For this one, we can take this loop. We can consider this loop, and we can use Kirchhoff's second law. So in this case, one thing we need to understand is that EMF of power supply, this will be equal to the voltage across lamp, means the potential difference across lamp, plus potential difference across this resistor, internal resistance R. So simply we can write down EMF is to 12.0 and potential difference across lamp we have just found. When current is 1.5, potential difference is 4.4, and current passing through this resistor, that is equal to 3.6 times R. So from here we can find value of internal resistance. So if we do calculation, internal resistance will be equal to 2.1 ohms. So this is value of internal resistance. For third part, question is simply asking us that the initial energy stored in the battery is this, and EMF, we need to assume that EMF of power supply and current in the battery do not change with time. We need to calculate the time taken for the energy stored in the battery to become 240 kilojoules. Or we can simply draw like this. Question is simply asking you the initial energy of power supply is this one. We can say this is EI, initial energy, and then it decreases to 240 kilojoules. We can say this is final energy. So this is the final, and question is simply asking us what is the time taken, means we need to find out what is value of delta T. So for this purpose we can simply say delta E in this case has to be equal to EMF of power supply times current passing through power supply multiplied by delta T. So simply we need to find the change in energy. So how we can find the change in energy? In this case we can simply subtract 240 from 470. We can write down 470 minus 240, and we need to multiply with 10 to 3. And EMF of power supply is given, that is 12, and current passing through the power supply, that is also given, that is 3.6, and we simply need to find delta T. If we solve this one for delta T, our final answer will be 3935 seconds. We can write down this answer up to 2SF. So simply we can say 3900 up to 2SF. So our final answer is 3900 seconds. Otherwise we can write down in standard form. We can say this is 3.9 times 10 to 3 seconds. For the last part, it is given to us that filament wire and copper wire, they are connected in series, and the cross-sectional areas and number densities are given. Question is asking us to calculate the ratio between average drift speed of free electrons in filament wire to average drift speed of free electrons in copper wire. So this is kind of typical question on transport equation, and this is our transport equation. Means I is equal to NQV. So we need to understand what is Q here. Q is the charge on single electron and its value is constant. This is 1.6 times 10 to negative 19 coulombs. First of all, let's try to draw one very simple table to write down the given data for filament wire. So this side, let's say, is filament wire, and here we will write down data for copper wire. So in this case current is the same, means current passing through filament wire, and copper wire is the same because they are just connected in series. We can simply say I is the same, but Q is also the same because this is a constant. So these two quantities are constant. So simply we can rearrange this equation and we can write down that I over Q, this is equal to N times VA. N times VA, and this ratio between I and Q, this is constant for these two wires, is constant. So simply we can write down the number density of filament wire and drift speed of free electrons in filament wire times its cross-sectional area, this is equal to number of free electrons in copper wire times average drift speed of free electrons in copper wires. So C for copper times cross-sectional area of copper wire. But question is asking you the ratio between drift speed in filament wire over drift speed of free electrons in copper wire. So we just rearrange this, then we can say this is NC AC divided by this is NF times AF. And the values of NC means number density for copper wire is given, that is 2.5 N, and cross-sectional area of copper wire is given, that is 360 times area of filament wire, cross-sectional area of filament wire. And number density for filament wire is given, that is simply N, and cross-sectional area of filament wire is given A. Now simply we can cancel A with A and we can cancel with N. If we just multiply these two, our final answer will be 900. So it means the ratio between drift speed of filament wire and drift speed of free electrons in copper wire, this is equal to 900. So this is our final answer. You can also understand like this: the speed of free electrons in filament wire is 900 times greater than Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on radioactivity from March 2021 paper 2. And this paper is for Cambridge AS Physics 9702. For part A, it is given to us the results of alpha particle scattering experiment provide evidence for the structure of the atom. According to result 1, or simply you can say according to first observation, the vast majority of alpha particles pass straight through the metal foil. In many books, they only mention gold foil, so it's the same thing, are deviated by small angles. Result 2, or the second result, according to this result, or according to this observation, a very small minority of alpha particles is scattered through angles greater than 90 degrees. From these results, we need to state what may be deduced from these results, means what we can deduce from result 1 and what we can deduce from second result. First of all, let's try to understand a little bit more about these observations. If you look at this figure, in this figure you can see this is source of alpha particles, and here we have detector, and here we have gold foil, means the metal foil. Now, if you look at this second figure, means if you look at only one atom. So this is representing only one atom. And you can see at the center of the atom is nucleus. And most of alpha particles, they just went straight through this atom. And this is our first observation. And this, according to second observation, if you look at this atom, you can simply see that from here, alpha particle is deflected back, and the angle it is deflected at an angle greater than 90 degrees, because this angle with horizontal is 90, and so this angle is greater than 90 degrees. And very few alpha particles, they scattered at an angle greater than 90 degrees. And this is our second observation, our second result. Now, according to first result, what we can say about structure of the atom? Simply we can say that, as you can see, most of alpha particles, they went straight. It simply means that most of an atom is empty space. So we can say most of an atom is empty space. So this is what we can conclude from this observation. This part has only 1 mark, and that is B1. So if you have written this mark, you will get 1 mark. Let's move on to second result. Now, question is asking us what we can conclude from the second result. According to second result, a very small minority of alpha particles scattered through angles greater than 90 degrees. So what this one is telling us, if you look at this one, first thing you need to understand why alpha particle is deflected back. alpha particle has a positive charge. So this is the charge on alpha particle. This is positively charged, and the charge on alpha particle is equal to plus 2e. If this is deflected back, it means there is an other charge is present that is repelling this one backward. So it means the nucleus is charged. So first thing we can simply say that from here nucleus is charged. It means there is positive charge in the nucleus. So nucleus is charged. So this is one point we can write down. The second thing we need to understand is that the mass of, from here we can also conclude that mass of an atom is concentrated in the nucleus, because most of alpha particle they went straight through. It means nothing is in this empty space. So the mass of this one is concentrated in the nucleus. So simply we can say that mass is concentrated in small region, or we can say mass is concentrated in nucleus. Simply we can write down mass is concentrated in small region, and that small region actually is nucleus. We can also write down in nucleus. So if you write down these 2 points, you will get 2 marks, because this part has 2 marks. The first mark is if you have written nucleus is charged, you will get 1 mark. And the second mark, if you have written mass is concentrated in nucleus, you will get second mark. And these 2 marks are B marks, means it has to be in your answer. For part B, it is given to us a radioactive decay sequence contains 4 nuclei P, Q, R, and S. It is also given to us nucleus S is an isotope of nucleus P. First of all, let's try to understand what is isotope. Isotopes are atoms of the same element with same number of protons. Means isotopes, they have the same atomic number, or simply we can say they have the same number of protons. So this is first thing we need to understand. Isotopes, they have the same number of protons, or they have the same atomic number. But isotopes, they have different mass number. Different mass number simply means that they have different number of neutrons, because they have the same number of protons. So the number of neutrons, they are different. And they're atoms of the same element, because they have the same atomic number. So number of neutrons are different. So this is one thing we need to understand, what is isotope. Now it is given to us nucleus S is an isotope of nucleus P. It means nucleus P and S, they have the same atomic number. So the atomic number of nucleus S is also 84. So this is atomic number of nucleus S. Now let's try to understand what is happening from P to Q. So when P decays to Q, you can see atomic number decreases by 2. So we can simply write down atomic number decreases by 2. And if we go from P to Q, the mass number decreases by 4. So it simply means this one is alpha decay. So we can write down this is alpha decay. Now if we look at the second one now, Q to R. So what is happening from Q to R? If you look at this one, atomic number increases by 1. But if you look at the mass number does not change. So simply we can say there is no change in mass number, but atomic number decreases by 1. So it is simply beta minus decay. So this one is beta minus decay. Now we need to understand what is happening from R to S. If we go from R to S, atomic number increases by 1. So we can simply say atomic number increases by 1. If atomic number increased by 1, so it simply means this is also beta minus decay. So this is beta minus decay, because atomic number increases by 1. So in beta minus decay, mass number does not change. So it means the mass number will not change. So these are the basic things we need to understand what is happening. Now if the mass number does not change, so the mass number of S is the same as mass number of R. So simply we can write down here the mass number for S, this is 214. Question is asking us the number of protons, determine the proton number and the nucleon number of nucleus S. Nucleon number is the same as mass number. Now simply we can write down from here proton number of S is 84 and the mass number of S is 214. This question has 2 marks. If you write down 84, you will get 1 mark, and this is the answer mark. So simply you need to write down 84 to get this mark. And the second mark is also answer mark. If you simply write down 214, you will get second mark. For our second part, it is given to us the quark composition of a nucleon in Q changes as Q decays to form R. We need to describe this change to the quark composition of the nucleon. First of all, let's try to understand what is nucleon. Maybe some of you are not clear what is nucleon. Nucleon simply is a particle in the nucleus. So simply we can say nucleon is a particle in the nucleus. So simply we can write down particle present in the nucleus. And examples of nucleons are protons, because protons are present in the nucleus, and neutrons are also examples of nucleons. Now if you look at this given nuclear decay means radioactive decay, we can see when Q decays to R, there is no change in the mass number. But if you look at atomic number is increasing by 1. If atomic number increases by 1, it means proton number increases. But the mass number is not changing. It means neutron number decreases. So simply from here we can write down, in this case, 1 neutron becomes proton, because number of neutrons decreases by 1 and number of protons increases by 1. So this is the first thing we need to understand. Now question is asking us, we need to describe this change to the quark composition of the nucleon. So in this case, nucleon, neutron changes to proton. We need to describe the change to the quark composition. Now if you look at quark composition of neutron, it consists of 1 up quark and 2 down quark, and proton consists of 2 up quarks and 1 down quark. So from here simply we can say that 1 down quark changes to 1 up quark, and that's all what you need to write down. If simply you write down 1 down quark changes to 1 up quark, you will get 1 mark, and this is B mark, mean it has to be in your answer. So simply if you write down this much, you will get 1 mark.